Thank you. For the last few years, I've been wondering about the same thing. I've been wondering about what makes a user think that the experience they have on their phone is a native app compared to a web experience. For example, a progressive web app. So what makes a user think that I'm using a native app compared to I'm using a progressive web app? So I made a couple of experiments, and I'll be showing you these experiments throughout the talk. And from these experiments, I realized something simple, but trust me, it's mind-blowing. From these experiments, I realized that native app is not about the technology when we think about it from a user's perspective. So can you imagine it for a second? From a user's perspective, native app is not about the technology. And the reason behind it is because from a user's perspective, native app is about this whole experience from the moment they start using the app all the way until the end. It's when the UX makes sense. It's when the UI is easy to use, when transitions are fast. It's when you go offline and things don't break, or you see the dinosaur. It's about all of these things together that makes the user think, I really like using this native app. What's more interesting, though, is that I ran these experiments on both developers and non-developers, so regular users. And both of these groups, developers and non-developers, were not able to tell that I was showing them a progressive web app. So both of them thought I was showing them a native app. And that's because the apps I was using in these experiments were meant to trick the user into thinking that these are built with native technologies. But again, it's not really about the technology. It's about how they look, how they feel, and how they're built. So when I realized that even developers were not able to tell that these are progressive web apps, this is when I realized that we as web developers have this massive potential on the web today. And that's why I'm really excited to tell you about those secrets, the secrets of native-like progressive web apps. So are you all ready? I'll take it as a yes. And when you're building for a native-like progressive web app, almost everything you're going to do is going to resolve around one of these three pillars. And that's the user interface, the user experience, and performance, and also the reliability. The focus on the talk today will be point number 2 and 3. For the user interface, I can simply recommend using either Ionic or the MDC web component, Material Design Web Component, because both MDC Web Components and Ionic have a goal of building a UI that looks like native apps. So that's going to help you a lot. So throughout this talk, we're going to talk about the UX, how extremely important it is, and also how if you have the best UX but really poor performance, they cancel each other out. So that's why I put them together. And finally, you're going to see how you want to keep showing the best experience, even if the user's offline, even if they use the app from the metro station, or even if they are on Li-Fi, which I'll talk about in a minute. So I think these things make the definition of a successful progressive web app, which is an app built with web technologies, but it exceeds user expectations. So that's what's really important about building successful progressive web apps. Because you can follow any tutorial on the internet, you can add SLAM scripts together, add a manifest, and you have a PWA. But I think if you think in terms of the user, that's not the point. The point is to make them enjoy the experience. So what are those secrets? I'm going to start with what I like to call as a prerequisite of building native-like PWAs, and that's designing and building an app shell. And that's my cat, more technically my neighbor's cat, but he's 90% at my place. He has a really Dutch name, you're not going to like it, Gijs, or Gijsje, which is supposedly cuter, but with a G, it's not so cute. And he's going to be with us every step of the way. Right now, you can see Gijs is in his own little app shell. So let's see what an app shell is. But first, who knows about the app shell? If you've seen my talk from last year, you probably heard about it. The app shell is a pattern we borrowed from native apps, and this is the app shell of the Twitter native app on Android. So just a split of a second before seeing the data, you have the app shell, which is made up of all of these components, for example, the floating action button. You don't necessarily need to have all of them, but this is an example. What's important, though, is that when I play, you're going to see the data coming inside of the app shell. So let's see it. It just goes inside of the app shell. This is a pattern users are used to a lot on native, on their phone. It applies for Android and iOS. Almost every single app has an app shell, even the camera app. That was mind-blowing when I figured it out. Even the camera app, just a split of a second before the camera loads, you have the app shell with everything, and the camera is just a black background. So let's see examples of other app shells. You have the Facebook app shell with stories, of course, because it's 2019, we should put stories everywhere. And this is the Google Photos app shell as well. And this is a pattern we've seen already in progressive web apps. For example, Flipkart had the app shell for a while. So these are PWAs. Same for the Twitter PWA. It's not completely new. And if you're wondering how to make it work, it's about inlining the assets that you need to render the app shell. So we're talking HTML, CSS, and potentially JavaScript. And you're inlining them because you want to give them full priority. Now, I understand this is a little bit scary, inlining, but you have to limit yourself to 20 kilobytes, at most 40 kilobytes. And that's because if you tell the browser everything's important, then nothing's important. So you should only prioritize a portion of it, which is the app shell. And the app shell serves as a first step for working offline. It's not the only way to do it, but it makes your life easier. If you see, I go on airplane mode, and I open this PWA, you see the app shell with the loader for a second, and then you see the data. We're going to talk about caching the data at a later stage, but for now, let's see how do we cache the app shell. And to cache the app shell, you're going to use, you can use Workbox, which makes your life easier. And if you're using Webpack as well, you can use the Webpack Workbox plugin. I'm not going to go too much in details into the code, but you'll have a link to the slides at the end, so you can take all the code. But this is the code you need for Webpack, if you're using Webpack, to use Workbox, which is going to generate a service worker and pre-cache the app shell. And when you install a service worker, you're going to have this network proxy sitting in between your app and the internet. And this gives you control over network requests. And for the app shell, you can decide to go directly to the cache, completely bypassing the internet. Let's see it one more time. So because I know a request is in the cache, I can completely bypass the internet, get it from the cache, and return it to the web page. And this allows you to serve the app shell reliably, whether you have a bad connection, whether you are offline, or doesn't matter. Of course, as long as you've cached it before. Now, let's see something more interesting after the slide. Building the app shell most of the times has a performance benefit, which is it helps you have a first paint, a faster first paint, because rather than waiting for all of your scripts to render and then show something on the screen, you're just showing the app shell as fast as possible. The first paint by itself is not that important, but the first paint could probably most likely means you can achieve a faster first contentful paint, FCP. So most of the times it helps you with that. So now let's see something more interesting, which is the first secret, the first official secret, which is building an advanced app shell. And what do I really mean by an advanced app shell? So as usual, I'm going to start with a native example. Does anyone know what this app is? Yeah, it's the Philips Hue light on Android. You probably noticed there's nothing special about it. It's just like any other native app. But if we think about it from terms of user experience, what's special about it is this, the tab bar. The tab bar over here is something we have, is a pattern we have in a lot of native apps when it makes sense. And it has a lot of benefits, which I'm going to describe now. The first one is that from a user's perspective, it greatly simplifies the user experience. Rather than having to go from a page, clicking on a link, then going to a third link, going to a fourth link, they are flat, and then the user immediately sees, I can go to one of these 4 pages. Inside the settings, I can go to another page, but it just makes the hierarchy of the app just much clearer to the user. It's also conveniently positioned at the bottom because when you're using your phone, you can easily reach it with your thumb. And from my experiments, I realized that as soon as you put a tab bar and you focus on the little details with the active, with the transitions, people will think it's a native app. Because this pattern, this is something we only see on native apps. So this is why it makes it look like a native app. Let's see another example of an advanced app shell. Let's play it again. So here you have the tabs again, and then you click on the events, you go to the events page, and then you click on one of the events, you get a dialog. And this is also another, I tricked you, hopefully. This is a progressive web app, but it just follows the same idea that you learned from building an advanced app shell. So what is an advanced app shell? It's just when we try to take the concept of the app shell a step further, just like they do in native apps. And I'm not saying every single website should have tabs, but some of the times it makes sense, and that makes your UX much nicer. So advanced app shells on the web are totally possible, but if you take a look around you, there aren't many websites that have advanced app shells. Or if they do, then the performance of it is just not so good to the point it frustrates you. So if you want to build an advanced app shell, you have to take care a lot of performance because UX and performance, they cancel each other out. And I have some tips for you on that. Most importantly, make sure to test on a real device because with the web, you're building on a machine, on a powerful machine, but the user is going to be on a mobile device. And there's a lot of difference in performance. Let's take a look at another advanced app shell example. And you can see with this one, I can use my thumb to slide between these pages or to flick between them. You can easily tell that this is a PWA because I didn't spend time on the design. But what's interesting here is that this is mostly written in CSS. There's only JavaScript to update the title over here. Everything else is built with the scroll snap CSS API. Has anybody heard about it? Has anybody used it? So 2 in 1. It's a really nice API and it works on all browsers. You give the container scroll snap type on the x-axis mandatory, and then you have to give the children an alignment, either start or center. Now, the second secret is reducing your JavaScript footprint because as we've seen, UX and performance, they cancel each other out. And this is Gijs overflowing from his little app shell. Now, if you have the best UX, but people cannot reach your main page, then they're just going to rage quit after a few seconds. And some important metrics here is the first paint, which we talked about before, and then you have the content that shows up after the app shell. That's the first contentful paint. And then normally you have 0.5 MB of JavaScript that's going to make your app not usable for a second or a few seconds. When it becomes usable, this is when it becomes first interactive. And of course, you want that to be as small as possible, so you want to ship as little JavaScript as possible. So I'm going to cover some tips, 3 or 4 tips that will give you, they're not low-hanging fruits, but they will give you a big return on investment. And the first one is something I also covered last year, which is using the module, no module split. And this allows you to ship ES 2015 to modern browsers without transpiling it with Babel, while also supporting older browsers. So let's see how it works. You write a script type module, you ship the app.js without transpiling, and then for older browsers, you use script, attribute no module, and then you transpile it with Babel. And this works because all modern browsers support type equals module and have an instruction to ignore this attribute no module. Whereas all the old other browsers, oh, it's just one. They have no idea what type module is, so they will not read it because it's not TypeScript or no type. And they have no idea what no module as an attribute is, so they will end up only reading this one. The benefits of this is two things. One, you'll be shipping less JavaScript for modern browsers because a class is just a class. It's not a generator function, etc. And the other benefit is that you're using the modern enhancements or speed improvements in browsers because, again, a class or a const is just a class or a const. Another thing you should definitely do is use this VS Code plugin. Does anyone know? Is anyone using it before I show the name? So if you take a look at it again, if you require Lodash like this, it's 70 kilobytes. But then if you require the sub package inside of it, then you're only using 2 kilobytes. So it's hard to be aware of these things. And this is why I recommend using the import cost plugin on VS Code, because most of the times, if you're shipping 1 megabyte of JavaScript, you're not writing this 1 megabyte. You're just importing libraries. So this makes you aware of what you're shipping. And this will often push you to find cheaper alternatives. And there's an amazing website called Bundlephobia, which allows you to search, for example, Moment.js, and you see this is going to take 4 seconds to load on emerging markets 3G. And then, do I really need it? Can I use a cheaper one like DateFNS? And it's a step in the right direction. This is what you should not do, but this is what we're used to, which is normally we write all of our files and we bundle them together in one app.js, and we serve all of that to the user. But the user ends up using only the home, the vendor, and maybe the help. But then we're still giving them the settings and the payment. So instead, you should use a technique, and this file is going to be huge. Instead, you should use a technique called code splitting. Has anybody heard about it? Yeah, half of the room. That makes me happy. And what code splitting is about is that you make the app.js contain only the minimum, and then you have a chunk for the payment, chunk for the settings, and a chunk for the help. And only if or only when the user needs it, you load it on demand. So then the user is not downloading things they're not going to use. The code for it is super easy. If you're using Parcel or Webpack, it just works out of the box. Technically, this is a browser API, but I think it still doesn't work on Firefox at the moment. But if you're using Parcel or Webpack, they'll polyfill it. And you just import with a function. So as a function syntax is important here. And when you import it as a function, it's only going to import it when the code is executed, not at bundle time. And this is going to return a promise, so you can resolve it. You can even access whatever was exported from it and call it. It's really easy to use, this technique, but it's also very easy to mess up on the UI side. This is why I have a couple of recommendations. So on localhost, every time you dynamically import something, it's going to resolve immediately, and that's because we're on localhost. But when you ship this to production, what your users will see a blank screen, and then they see the content. So if you're lazy loading, or if you're importing something that is visible on the screen, make sure to show a loader, some kind of indicator that this is coming from the network. You can also go a step further, and if you're loading like a big file, you can say loading, and then after 2 seconds, still loading. So because on Fast3G, if you have to load half a megabyte, like a cryptography library or something, it will not load faster than 2 seconds or 3 seconds. So then you can expect that and then set a timeout and manage it and show that. And sometimes if you're loading the whole page, like the settings page, you can even show a retry button if it fails. So you can have a .catch here and then show a retry button. You can even take it a step further. I'm actually using this in one of my projects. You can detect slow connection. It doesn't work on all browsers, but with this code, it doesn't break. So navigator.connection.downlink. If it's less than 1, then the user is on a slow connection. And based on the result of this function, you can decide to dynamically import, for example, a 4 megabyte file versus a 1 megabyte file. My use case is I have to load an editor, and if you're on a slow connection, I load the lighter one. So that's really nice. Oh, and I love this tool. I never go on production when I make major changes without using Webpack Bundle Analyzer or Source Map Analyzer. because this app reminds me how many mistakes I can make when shipping JavaScript projects. Some of the things you can realize is that you shipped a Node library to the browser, even though you shouldn't, or you shipped 2 versions of Lodash for some reason, or you're shipping the entire Lodash library, whereas you only need one of them. It's just a nice tool that visualizes your app to JavaScript or other chunks you create, and then you can see, why is this one so big? What am I doing wrong? Or maybe I can realize that I definitely don't need Bluebird, but maybe I can lazy load something else and remove it out of the main chunk. So it's a very useful tool. Now, the third secret is don't be like Gijs, and instead you want to react with fast interactions. And we know that from physics that, I like how everyone's just looking at it. We know that from physics that every action needs a reaction, and that's especially true when it comes to UX. It's probably more important in physics, but that's what I'm talking about today. So for example, if you have a login button or any kind of UI element, if the user clicks on it, you want to immediately tell them that we received your action, we're working on it. This could be a ripple effect or an active, depending on your app. But then the challenge here is that sometimes you click on a button and then you give the browser 20,000 lines of JavaScript. Not because this is bad code, but just because you have to do a lot of things on one click of a button. And then there's no way for the browser to run it in less than 90 milliseconds, especially on mobile. And when it takes more than 100 milliseconds, the user is going to start feeling disconnected or maybe even distracted. I clicked on a button and nothing happened. So what you can do here is use this really powerful API and dangerous request idle callback. Has anybody heard about it? Has anybody used it? Keep your hands up. Has anybody used it properly? Maybe. So we had 3, 2, and then maybe. I've never used this API properly from the first 3 times, but it's really powerful. The way it works is it allows you to schedule some work into the future when the browser has time to breathe. So the browser will call your callback when it has between 1 and 15 milliseconds before rendering the next frame. So it's very powerful, but also quite dangerous, because if you schedule a lot of work, then you're going to cause the next frame to be missed. And it's also hard to use because what can I run in 1 millisecond? We don't really know. It depends on the device. It depends on what you're trying to run. So what I recommend is that if you're going to call it, always call it with just a minimal instruction, like, for example, sending an analytics event, or the least amount of code you could have. And also always profile before and after using it, because it's just hard to know if it's working properly or not. But if you profile before and after, you can see if it's actually making it working as expected. And right now, it still needs a small polyfill on Safari that relies on set timeout. If you want to talk more about this, find me after the talk. I can show you some of the use cases I had. But the benefit of this is that you can, rather than giving the browser 20,000 instructions at the same time, you start with the most important ones and you delay those that are not super critical. So then you allow the browser to render the next frame, you allow the user to start using your app, and every time there's some idle time, you continue with the other ones. And when you put all of this together, you can build a truly... Wait, does anybody know this app? Thank you. It's not. This is a progressive web app. But when you put all of this together, you can really build an experience that is convincing. If you take care about the UX, the transitions, the animations, I can show you this on my phone. It's not a full app, so if you try to swipe right and left, it doesn't do anything. But it was one of the experiments I used to trick people to see if they believe the web can do that. Fourth secret is how to make your app work offline, but also how to make it work offline properly, because there are some gotchas over here. So we saw here that if you go offline, and then we open Twitter, for example, we see the app shell, and then we see the data. We already talked about the app shell, but now how do we cache the data? So if you're using Workbox, there's the routing module, which allows you to register a route For example, you can say here, every time the main page goes to API/whatever, I'm going to use the network first strategy. And the network first strategy means it's going to go to the network. If it works, that's good. If not, then it's going to fall back to the cache and give us a result from the cache. So this works, but I recommend every time you use network first to try and use the network timeout seconds. And that's going to let you fight Li-Fi. Does anyone know what Li-Fi is? Yeah, 3 people. So the Li-Fi is when you are connected to the router, and the router doesn't really have internet. So your phone or laptop is going to think that it has internet, but it doesn't. It only gives up on the request after 60 seconds, and that's a lot. So with this, you can tell it to give up on the request after, for example, 5 seconds. So if it takes more than 5 seconds from the network, let's just cancel it and go to the cache. There are, of course, other strategies like the cache first and the stale while revalidate. Cache first goes to the cache first, and then if it doesn't find it, it goes back to the network. And stale while revalidate goes to both the cache and the network at the same time. Most of the times, the one from the network will come back first, from the cache. So you get the results from the cache on the screen. And in the background, you're getting a response from the network that's going to update the cache for the next time you use it. So that will be useful if you have a list of countries. You know they're not updated frequently, and if it updates, it's fine if we see it the next time. You can use stale while revalidate. But of course, something extremely important here is to be mindful of the user storage, because it's so easy to add megabytes and megabytes of storage on the user's device. So I recommend that you use the Workbox expiration plugin whenever possible. It's an excellent plugin. You can define the number of entries to keep at most, for example, 50. And if you have 51, it's going to remove the older one and add the new one. And or the max age seconds, so how many seconds do you want to keep it. So for example, if you know that the list of countries might change once a week, you can cache it for a full week, and then get it from the cache for a full week. And then after that, you get it once from the network and cache it for another week. And just a tiny trick or tip, the cache API that is being used in the service worker can also be accessed on the window scope. So this caches API is being used in the service worker, but at the same time, you can access it on the window scope. And this will help you prevent a lot of bugs. If you're caching user-related information in the service worker, when the user logs out, make sure to clear them, because then you don't want to have a user logging in, then logging out, then logging in with another user and having information from the old user. So this is how you can do it on the window scope. Now, the fifth secret is how to ask your users to add the app to the home screen, but also how to increase this conversion, because there are so many pop-ups on the web, and I'm not going to teach you how to annoy users even more. Instead, I want to show you how you can increase this metric. So first, this is an API that works on these 3 browsers. 2 of them also supports it on desktop. And it's called the app install banner, which allows you from JavaScript to show a native banner that asks the user if they want to add it to the home screen. It shows up when there are some requirements met, like having an app, like having a service worker, having a web app manifest, etc. And when should you show it? So if you show it in the beginning without context, just like with the push notifications, it doesn't make sense. It's like going out on a Tinder date and asking them, do you want to marry me on the first date? That's just completely out of context. So you have to wait until the user is engaged. So I'm going to show you an example of how I did it. A quick backstory is I have an online course that teaches JavaScript interactively. It's a web app that you can also use on your phone. And when you finish 2 lessons and 2 challenges, the course tells you that we have a flashcards app as well. So go to that URL, and then you land here. Okay, at this point, you have no idea how this ties to the course. So imagine yourself, you're a user now, and you click on one of the buttons. And you start getting questions based on the course, based on the things you learned. Let's fast forward it. So by the time you reach the end of it, you already made up your mind if you like the app, if you think it's relevant for you. And this is when we tell you, practice daily, add to home screen. When you click on it, you get the app install banner. This is native. Click add, and now you have this app on your home screen. And this will allow you to maximize the conversion, because if you show it out of context, people are not going to relate to it. They don't need another icon on their home screen. The code for it is super simple. The only note I have is make sure to send the result.outcome to your analytics server, because then you can understand what kind of devices, what kind of network types are accepting or dismissing this add to home screen prompt. And for the last secret, it's about building a smooth update process. And that's because when you have a service worker and you have the app shell, you've essentially become an app, but without the store. The reason behind it, I'm going to move the GIF, no one's focusing on me. The reason behind it is it's just like an app. If you open an app right now on your phone, it doesn't really have to be the latest version of the app shell. It could be an older version. You can only update it by going to the App Store. So same thing with your PWA. The app shell that you're seeing might be out of date, but then the browser is going to check, see if there's a newer version, and then you can ask the user to update. So I'm going to show you how to make this process. But before, I have to explain how does the service worker gets installed and how it updates. So this is a simplified, the simplified lifecycle of a service worker. First, it gets parsed. This is when the browser checks there are no syntax errors. And then it gets installed. And then it's a waiting phase. So the browser asks, so the service worker asks the browser, is there any other service workers installed on this domain? If not, we don't have any, so it's going to activate. And when it's activated, it means it's controlling the current page. So network requests go through the service worker until it becomes redundant, and then it's not used anymore, and then it's, this service worker is just not running. But now, let's say that this is service worker version 4, and we want to update to service worker version 5 or newer. Keep in mind, we don't really have versions. It's just this is an older one, and this is a newer one. So this is just for simplification. So how does the update process work? Because this one is currently activated, and the browser is going to realize there's a newer one. It's going to parse it. It's going to install it in parallel with the old one. But in the waiting phase, it's going to realize, oh, there's another one active, so I cannot activate two at the same time. So what's going to do is it's going to wait for your green light, which is by calling skip waiting. The skip waiting method allows you to tell that you want this service worker to take control. When you call it, the new one becomes activated, the older one becomes redundant. We reload the page, and now the user is on a new version. It sounds complicated, but this guarantees that you have the proper consistency of your app. Now, you've seen this before. A new version of Inbox is available, or there's a new version of this. Click to refresh, click to update. How can you make this work? I'm going to show you the code in a minute, but I want to talk about the UX part of it again, because that's important. And this is where I want you to take inspiration from native desktop apps, because native apps are not so good at doing this. If you're updating an app from the store and you're using it, it just closes, and then you have to open it again. But with native desktop apps, they've done a really good job with the, not an official name, I like to call it the update dot. And that's something you might know from Spotify, Google Chrome, and other apps. Do you know when Google Chrome wants to update, it switches the overflow menu to green, and then orange, and then red? This is what I mean by the update dot. And you also have it in Spotify, because Spotify wants to tell you that there is an update, but they don't want you to stop listening to music to update the app, because there's no point in it. So what they do is they show you this tiny little blue dot. It may or may not catch your attention, but if it does, you can click on it and you can see there's a new version. This is what I mean by the update dot. If Spotify was showing me a toast every single time, it would be a bit more annoying. But of course, this depends on how important the updates are for your app. So I've decided to do the same technique. This is my course. It's the first time you see it, so I don't expect you to see the update dot. But if you do, it's over here. And then again, because I want you to continue using the app, but if you notice that something's wrong, or if you notice that you haven't updated in a while, you can take a look over there, click on it, you get a drop-down, and you get a button that says, update the app. And then when you click update, it's gonna call skip waiting, reload the page, and you're on the new version. The code for it is slightly more complicated, but that's because part of it is running on the service worker scope, and the other part is running on the main scope. But if you have questions about that, you can let me know afterwards. So now we have time for questions. How much time do we have?
10 minutes, easily.
Yeah. I still need to wrap up afterwards, but it's only going to take 3 minutes. So any questions? Yes.
How good does a well-designed PWA work on iOS?
Great question. The question is how good. Yeah. The question is how good does a well-designed PWA works on iOS? So there are things that don't work on iOS, like the add to home screen, or it works. It depends. So I can give you in my example, I'm not using it because when you add the PWA to the home screen, I want you to log in with GitHub. But because when you add it to home screen on iOS, it adds it completely separately from Safari, you have to re-log into GitHub, and that's annoying. So that's something I'm personally not pushing for, but you can push for it if it makes sense for a use case by telling the users, click on share, and then you can find it here in the add to home screen, and that works. There are a couple of bugs as well, so I would recommend just testing a lot. It's really important testing. Also, with every new iOS versions, there are some things fixed. Sometimes there are some things broken, so test a lot. Push notifications don't work on iOS at all. You can go with progressive enhancement here if it makes sense, but I understand for some businesses, if you cannot do web push, then the whole product is useless. So it's always a matter of depends. But if I can talk a little bit about the business use case, with a PWA, you can enter a new market in just 2-3 months compared to having to build 2 native apps. So sometimes it's just so much faster, easier, and cheaper. And sometimes, no, you really need to have 2 separate native apps, depending on the API usage.
I can add, if you wish to go into details, what works and doesn't on iOS, just Google for PWA police, it's GitHub repo where I gather these points, like what doesn't work at iOS at the moment and how to work around it if possible. We had the questions somewhere there. Just yes, say aloud.
When I hear about progressive web apps, you're often talking about web apps, progressive web apps instead of apps. Why aren't we talking about both? Combining the best of both worlds, having a good or better web experience than you would expect, and then have an app in addition.
So if I get the question right, you're asking why not have a progressive web app and also a native app at the same time?
Yeah, I know lots of companies are doing both.
Yeah.
But when we're talking about progressive web apps, you're often talking about instead of apps.
Okay, so the question is, why do we always talk about progressive web apps instead of apps? I would say, like, I have a course on progressive web apps, and in one of the slides I do mention that the strategies you can use is either as a replacement because it's cheaper and you can have the same team, or it's just a new way to reach markets where they cannot install apps. So I do say there's there's this benefit as well, but I think people are always more interested in the one that is faster, cheaper, and then easier to deploy. So there's definitely a use case for it. Also with trusted web activities, you can publish the PWA itself to the Android App Store. And so, yeah, that's it. Any other questions?
By the way, do you want to see real-life example of PWA? Just go to website of Mobile Era, mobileera.rocks. It's a progressive app. You can install it on your Android device. And if I set up everything correctly, it should work. If not, you can blame me or dear maintainer of hoverboard repo, which mobileera.rocks based on, our dear speaker, Abraham. Yes, but yeah, it should work. So you can try it, you can test it. Just go to mobilearrow.rocks, and if you, especially if you run Android device, you should get a prompt to install this, and then you can turn off Wi-Fi. Should work. And yeah, this year we don't even have Android application. We have separate iOS app for our website. But yeah, PWA is a real life thing. Yeah. More questions?
This was an unexpected advertisement, but okay.
It's useful, yes. Yeah,
All right, any more questions before we wrap up? Just before that, if you want to talk more about the business use case, I'd love to talk about them, but I just don't want them to be recorded, so we can talk afterwards.
Yeah, Abraham, your question.
Yeah.
How do you get any work done with that cat hanging around?
For real?
Please repeat question.
But I'm not sure if that's the question.
That's my question.
So how do you get real work done with the cat laying around? It's not my cat, it's for the neighbors, but just give him food once and then he's there forever, but I'm not doing that anymore. All right, let's wrap up. So if you notice, it's all about the attention to details. So everything, the UX, the performance, if you have an advanced app shell or the tabs, you want to make sure that it's very convincing. You want to pay attention to how fast it goes to the next screen. You want to pay attention that you're giving this kind of feedback to the user. It's all about this attention to detail. And if you go back to the PWA example that I showed you before, the one with the bank, I did not design it because I don't have the design skills. What I did is I simply cloned the design from a native app. And this got me thinking that when we're building a native app, we hire the best UX designers. But on the web, we let, with no offense, we let backend engineers do it because they can. Yes, they can, we can. Like, even I'm a front-end specialist, but I cannot build great UX. I cannot design them myself. I can build them. But maybe if you want to build successful PWAs, we should invest in hiring the best UX designers, mobile UX designers. So what I did after this talk is I tried to apply everything I learned while doing this talk. So I'm going to show you the before-after of my course, the same course you saw, but on mobile. This is how it used to be. It was a responsive web application, which means I added a media query that changed the grid into display block, and then I'm done. But of course, it's not super satisfying. This was before. You have the text editors, and everything's under each other, because that's how we're kind of used to make things work on mobile. But I decided to improve it based on the things I've made in the talk, and this is the version afterwards. You can slide between the tabs. There are 4 distinct tabs. You can even click on a tab and then go from one screen to the other. And there's just a lot of details that go in it. Like, for example, the number of tests, which is something important, shows up prominently over here. The floating action button, the small one, only shows up when you complete it, rather than having it always showing but disabled. So it's really about the small details. And this transition from here to here took 4 hours to code, because I'm used to doing these app shells, but took twice the amount of time to think about the UX. So that's my main important message here. To be able to prototype it, test it with users, see what makes sense, what kind of challenges, and it's nowhere near perfect. I do have a lot of issues with it that I want to fix it. It's just, I hope you can see the transition. And my last message for you is that let's just go and build progressive web apps our users will absolutely love. Thank you.